Every tire you will ever purchase will sooner or later end up in a scrap pile. Even through normal usage, all tires experience fatigue and will eventually become scrapped. They also encounter road hazards that cause non-repairable damage and end their life prematurely. Tires are also subjected to abusive conditions for which they were not designed. There are many reasons why tires end up in a fleet scrap pile. All too often, once a tire is determined to be junk, the ledger is closed and the tire is forgotten. However, there may be things to be learned from these tires that could help lower your overall tire costs. By incorporating a review of scrap tire inspections into your maintenance program, it may be possible to institute changes in your fleet's operations, maintenance practices, or tire program, which can give greater value to the tire dollars you spend in your operation. To understand the different types of damages that can happen to radial tires, it is helpful to know how a radial tire is put together. The foundation for the radial tire is the construction of the specially designed bead bundles. Steel cord material is wrapped radially between each bead bundle. The steel belts are laid over the radial casing to add stability and protection against road hazards. The rubber products are an integral part of the radial tire and are added during various stages of production. Butyl rubber is used in the interior of a tubeless tire to reduce air loss. Special aging-resistant rubber is applied to the sidewall to protect the steel casing ply. Finally, an abrasion-resistant rubber is added to the crown of the tire for additional protection and to enhance traction and mileage. The approach to scrap tire inspection should always be systematic. You should have the following tools in order to make a scrap tire inspection: a clipboard with forms or other systems for recording your data, a tire crayon, blunt probe, tread depth gauge, and a pair of heavy-duty gloves. Another tool which is very useful is spreader pliers or snap ring type pliers. This tool enables you to open up an injury to see the extent of the damage. We are now ready to begin our inspection. Forms and systems are available from Michelin to aid in collecting this information. Record the necessary tire information such as tire manufacturer, tire size, tread design, ply rating, remaining tread depth, the number of retreads, the retread DOT date, and the tire manufacturer's DOT date. Specifically, the last 3 or 4 digits show the week and year the tire was manufactured. Keep in mind, most manufacturers use a triangle indicator located after the DOT number indicating the tire was manufactured in the 1990s. If there is no triangle, it would indicate the tire was made in the 1980s or earlier. For year 2000 and beyond, you will find the week is a 2-digit number and the year is a 2-digit number. Once this data is recorded, you are ready to begin a thorough inspection of the tire. Ensure that you have adequate lighting. Mark a line across the tire tread, which will indicate the beginning of the tire inspection. Inspect the tread area first. Be sure to probe all injuries. Next, inspect each sidewall, including the bead area. Then, place a line on the interior of the tire and thoroughly inspect the interior, starting at one bead and ending at the other bead. Sometimes the cause of the damage is obvious. In many cases, however, we are only seeing the effect. The actual cause is what we want to determine. All scrap tire failures are cause and effect related. In the majority of the situations, it is the effect that we first see when we look at the tire damage. However, tire condition effects may have many causes. It is important to investigate and identify these causes. Often a pattern can be found which may identify changes needed to avoid future scrap failures of this nature. Surprisingly, the majority of tubeless commercial scrap conditions are found in the following 5 damage categories: Runflat, air infiltration, pinch shock, impact damage, with or without a casing ply rupture, and fatigue damage, with or without a casing ply rupture. A run-flat condition is created when a tire has operated at very low air pressure relative to the vehicle's speed and load being carried. Industry standards define run-flat as a tire operating at less than 80% of the fleet's operating air pressure. Low air pressure can be the result of a cut or any foreign object entering the tire, as well as leaks in any part of the valve and wheel assembly. The excessive deflection due to the low pressure causes the internal products of the tire to build up heat, resulting in the breakdown of the bonding agents in the tire. There are two types of run-flat conditions observed on tractor-trailers based upon the position on the vehicle and the degree of air loss experienced in the tire. Tires mounted singly, as found on steering axle positions and on some tag or lift axles, will have a defined run-flat look. As the tire's deflection increases, the sidewall approaches the ground. There is a buildup of heat, which is indicated first as a series of stress marks or a darkened ring on the inner liner of the tire. The next level shows a series of blisters which form on the tire's inner liner. At this point, the heat buildup causes the rubber products to break down and the steel casing plies to separate. Once sufficient separation exists, the remaining air pressure will evacuate through openings in the sidewall rubber, which can generally be heard by the driver. Once the air is out of the assembly, the tire is sandwiched between the wheel and the road. If the tire continues to run, the tread and belt area is usually torn off of the casing. The casing is then further shredded between the ground and the wheel. If a slow air leak is the cause, you will generally see a ring worn into the tire's sidewall. This condition occurs from the sidewall running along the ground as the tire deflects down. This ring is generally found only on one side of the tire on a rigid axle vehicle. In the case of rapid air loss damage, such as a large sidewall injury, there will be no ring worn into the sidewall. A tire which is run flat on dual tire positions will have a different appearance. Since the deflection of the tire is lessened by the support of the other dual tire, it takes longer for the results of run flat to be seen and damage to be created. However, damage from this type of run flat will eventually be as dramatic as if it ran on a single tire position. To accurately inspect a run flat for its cause, it is important to gather as many of the pieces of the tire as possible. The pieces can be fit together, showing a clear picture of the cause. Remember, a wheel was part of the assembly and should also be inspected as a source of potential air loss if no obvious cause is found in the tire. Dual wheel run flat conditions will be discussed in more detail later in this video when we look at zipper damage. The next scrap tire condition is air infiltration.